All right, in this video we're going to look at the Chapter 15 review problems, and these are on page 773 in your textbook, or that's where they start. So if we look at the first one on the list is number 5. And what we're doing on number 5 is we have two lists. The list below represent the ages of actors and actresses at the time that they won an Academy Award between 1980 and 2008. Part A says represent these two sets of data on a single stem and leaf plot. And Part B says do you notice any patterns in comparing the two plots? So if you recall a stem and leaf plot, and since we have two sets of data and we want it on a single stem and leaf, that's going to be what we call a double stem and leaf. And so we're going to have a stem in the middle, and that stem is going to be the first digit in their age. So it looks like the smallest, the youngest age, let's see, we've got some in the 20s. Looks like that's the lowest. And then the highest looks like we have one that's in the 80s. So our stem here is going to be 2, 3, 4, 5, 6, 7, and 8. And then on one side we're going to have the actors, and on the other side we're going to have the actresses. And what we want to do is we want to go through this list and put in these names where they would go. And you could go ahead and put these in order, but you wouldn't need to necessarily. So if we look at, say, the actresses, the first one is 31. So I'd put a 1 here with the 3. That would represent a 31. The next one is 74, so I'd put a 4 down here. Next one is 33, so I'd put a 3 up here. 49, 38, 61, 21, 41, 26, 80, 42, 29, 33, 35, 45, 49, 39, 34, 26, 25, 33, 35, 35, 28, 30, 30, 29, 61, and 32. So here is my stem and leaf for the actresses. And then I need to do it for the actors, so I'm going to do the same thing but over on this side. So I have 37, 76, 39, 52. And you'll notice I'm trying to line these up so I kind of have, it's kind of acting like a bar graph here. So let's see here, 39, 52, 45, 35, 61, 43, 51, 32, 42, 54, 52, 37, 38, 31, 45, 60, 46, 40, 36, 47, 29, 43, 37, 37, 38, 45, and 50. And then what you want to do is you want to just look at those two sets, and you'll notice that on both of them you have your largest number that are in their 30s. But you can see that for actresses, you have a lot more that are younger, whereas the actors, you have a lot more that are older. You have a wider spread among the actresses. You start at 21 and go to 80, whereas the actors, you start at 29 and go to 76. So you can kind of see how those things are spread out and how they relate to each other. So that's number 5. The next one is number 6. And number 6 says, the following is the number of regular season wins by the Detroit Pistons over 12 seasons ending in 2008. And so here's our numbers. We have 59, 53, 64, 54, 54, 50, 50, 32, 42, 29, 37, and 54. All right? And we want to find the mean, median, and mode for that distribution. Now, one way we could do that is we could say, all right, our mean is we're going to add up all of these numbers. Okay? So if I add up all those numbers, let's see, 59 plus 53 plus 64 plus 54 plus 54 plus 50 plus 50 plus 32 plus 42 plus 29 plus 37 plus 54, I get 578. And we had 12 seasons, so we're going to divide that by 12. And that's going to come out to be about 48.167. And that's our mean. Now for our median, what we need to do is we need to take this set of numbers and we need to put it in order from smallest to largest. So if we look at it, our smallest is 29. Then we have a 32 and a 37. And then we have a 42. And then we have two 50s. We have 53, 3 54s. A 59 and a 64. And now to find the median, what I'm going to do is I'm going to look for the halfway point. So if I go in 6 from each side, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, you'll notice that the median is actually right between these two numbers because there's 6 on either side of those. So I need the median, which is going to be halfway between those. So I'm going to take those two numbers and find the mean of those two numbers, which is going to give me 51.5. So that is the median. And then the mode is going to be the number that appears most often, so that's going to be 54, so 54 is the mode. Or you can do these on a calculator as well, and what we would do is we'd go into the Stat menu, and we go to Edit, and if you've already got stuff in there that you want to clear out, you would go up and highlight the L1 and hit the Clear button, which is right here, and then hit Enter, and it'll clear out that list. And then you can go ahead and put in your numbers, so 59, 53, 64, 54, 54, 50, 50, 32, 42, 29, 37, and 54, and you've got 12 numbers in there. And then you go back to Stat, and now you move over to Calculate, and you want to calculate one variable statistics. You could put in L1 if you want to, that's the second function on 1, or it's automatically going to go to L1 and do that. And you'll notice that what you get here is you will get your mean right here at the top. Notice that's the same as what we had. You'll also get your median down here when you arrow down, and here's our median, which is 51.5. It does not give you the mode, okay, but it will give you the other pieces of information. Okay, so that's number 6. The next one that we want to look at is number 10. So number 10 says, calculate the simple standard deviation for the following distribution. So remember what we're doing, we're finding standard deviation, is the first thing we need to do is take our numbers 4, 6, 7, 3, 5, 6, 4, and 5, and we need to find the mean of all those numbers. So the mean is the first thing we'll find, and we'll add up all those numbers. So let's see, 4 plus 6 plus 7 plus 3 plus 5 plus 6 plus 4 plus 5 gives us 40. And there are 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we get 5 is our mean. And now what we want to do is we want to find out how far each of these numbers is from the mean. So what I'm going to do is I'm going to set a chart that's going to have my different data points and how far those data points are from the mean. So my data points are 4, 6, 7, 3, 5, 6, 4, and 5. And since my mean is 5, 5 minus 4 is going to give me 1. 5 minus 6 is going to give me a negative 1. 5 minus 7 is going to give me a negative 2. 5 minus 3 is going to give me a 2. 5 minus 5 is a 0. 5 minus 6 is a negative 1. 5 minus 4 is a positive 1. And I get another 0. So that's my distances away from my mean. Now what I need to do is I need to take all of the numbers and I need to square them, because I want to find the average distance from the mean, or the mean from the mean. But if I was to find the mean of all these numbers, notice they would just all zero out. So in order to get rid of the negatives, I'm going to square all these numbers. So I get 1, 1, 4, 4, 0, 1, 1, 0. And then I'm going to add those numbers up. Okay, so that would be, let's see, 8, 9, 10, 11, 12. And I'm going to divide. I'm going to take the 12, and I'm going to divide it by n minus 1. So n in this case was 8. So I'm going to take the 12 and divide it by 7. And then that's going to give me the variance, and I'm going to take the square root of that to get the standard deviation. So 12 divided by 7 is 1.71428, blah, 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 blah. And I'm going to take the square root of that, square root of my answer. And you can do that on the calculator by using this key right here, second, and it'll just take what you did before and use that as your answer. You don't have to type the whole thing in again. And we get 1.31 when we round that off. So, and the notation we use typically is standard deviation of x is about 1.31. Okay. You could also do this on the calculator. So if you go into the calculator, go into Stat, and here I'll show you how to clear out. So we'll go up here, and then I'll hit Clear and hit Enter. And then I'll put in my numbers, 4, 6, 7, 3, 5, 6, 4, and 5. I've got all 8 numbers. Now I'm going to go to Stat and calculate one variable statistics on L1. And notice this one right here is what my standard deviation is. This other number down here is another type of standard deviation when we use just plain old n down here instead of n minus 1. Okay, but you're going to want the one that looks like it's saying Sx. Okay, that's your standard deviation. And number 11 says explain what the standard deviation tells you about the distribution. Well, number 11, we can say it measures the spread of the data. How much it's spread out. Okay, is it all lumped around the mean, or is it fairly varied from the mean? And since we have such a small number here, that means it's fairly close, and you can see that from looking at it. If we'd gotten a number like 3, then we would have numbers that would have been, a bit farther away. So that's number 11. All right, let's go to number 14. Here's the next one. And number 14 says, if a distribution has a mean of 60 and a standard deviation of 5, the z-score 1.35 corresponds to what raw score? So for this one, we need the formula for z-scores. And the formula for z-scores is that the z-score is equal to the raw score minus the mean score divided by the standard deviation. So in our case, for this one, we're going to plug in what we know and then solve for what we don't know. So they told us we had a z-score of 1.35. We don't know our raw score. We know our mean is 60, and our standard deviation is 5. And now I want to solve that equation for the raw score. So I'll start by multiplying both sides by 5. So 1.35 times 5 is 6.75. And the 5's over here will cancel. And then I'll get raw minus 60. So I'll add 60 to both sides. And I get that my raw score is equal to 66.75. All right. And what that's telling me is that a raw score of 66.75 is 1.35 standard deviations away from my mean, which is 60. All right, next one is 15. And for 15, it says, assume that 1,000 scores are normally distributed with a mean of 72 and a standard deviation of 4. How many scores can we expect to be between 75 and 82? Now, there are two ways to go about this. One of the ways that you can do this is by using the calculator and using the normal CDF function. And the normal CDF function, when you plug it in, it's going to ask you for 4 different things. It's going to want to know, it's going to tell you what percentage are between 2 different scores. And so you need to have the low score, comma, high score. Then you have to tell it what the mean of the data is and what the standard deviation of the data is. So I'm going to use that notation for standard deviation. So in this case, normal CDF, our low score is we're looking at something between 75 and our high score of 82. We have a mean of 72, and we have a standard deviation of 4. And I'm going to plug that all into the calculator. And let me just show you where that is. If you go to the distribution menu, which is right here, second vars, and the second one down is the normal CDF, so I'm going to go down and choose that. I'm going to plug in my scores, which were 75, comma, and the comma's right above the 7, 82, comma, 72, comma, 4. And I get about 0.22. So that means 22% of the scores are within that range. So if you have 1,000 scores, 22% of 1,000 is 220 scores. Okay, so that's how many are in that range. The other way you could do it is by using the z-score table, which is, let me find it here, it's back, it's on page 754. But in order to use the z-scores table, what I'd have to do is I'd have to have z-scores for both sides. So I'd need to find the z-score first for the high number, which is 82. So it'd be z-score is the raw number, 82, minus the mean, which is 72, over the standard deviation, which is 4. So that gives me a z-score of, let's see here, 10 over 4, which is going to be 2.5. And then I would need a z-score for the second one, which would be 75 minus 72 over 4, which is going to be 0.75. And now I would need to go to that table on page 754, and I would need to find the A values that are associated with those Z values. So if I go to a Z value of 2.5, let's say, here we go, 2.5, the A value is 0.494. So the A value for this is 0.494. The A value for this one, 0.75, let me just look that up, is 0.273. Now, what this A value tells you is this tells you the amount of area that's between 72 and 82. And this is the amount of area that's between 72 and 75. So if you took this number, so if you look at a picture, alrighty, here is, say, the 75, and here is the 82. The first number gives you all of this area right here, and this number gives you this area right there. So if you want the amount that's between these two, what you do is you'd start out with this number, all of that amount, and subtract off this piece. So 0.494 minus 0.273 comes out to be 0.221. Pretty much the same as what we got up here. Okay? So 22.1% of 1,000 would be 221 scores. So either way is fine, whatever way works best for you. Now, let's see, what's the next problem here? We have problem number 16. All right, problem 16 says, suppose that you earned an 82 on a history exam that had a mean score of 78 and a standard deviation of 3. You also earned an 84 on an anthropology exam and had a mean of 79 and a standard deviation of 4. On which exam did you do better in relationship to the rest of the class? So in order to figure out which one you did better on in relation to the rest of the class, what you're going to do is you're going to look at z-scores to see how you land on the curve based on the two different scores. So we're going to find the z-score for both. So for the history, we had an 82 for our raw score, and our mean was 78, and our standard deviation was 3. So that's going to be 4/3, which is 1.33 approximately, and that's for our history. And for our anthropology exam, we had an 84, so higher exam, but notice that the mean is higher and the standard deviation is higher. So when we do that one, we're going to get 5/4, which is 1.25. So when we look at that in relationship to where they lie on the normal curve, this one is going to be higher on the normal curve than that one. All right, you did better in relationship to the rest of the class here than you did here. So the history one is going to be the winner. So those are the problems from chapter 15. Also, just note that that table that we looked at from page 754 is going to be included as the last page of your exam. So you won't need to try and put that on your note sheet if you're using that instead of the calculator.